Hello, welcome back. In this session, we are going to see the importance of aggregation before doing the calculation. So in our database, we have two tables, EMP and employee bonus. If I run these queries, so I have 4 records in the employee bonus table, and out of those 4 records, 2 records are related to employee number 934. And here the bonus type means 1 means 10%, 2 means 20, 3 means 30, something like that. Okay, and this employee got two times bonus on March 17th, Feb 15th. So these are not in sorted order, but that's okay. And all these employees 934, 839, 782 are from the department number 10. So to make sure that, let's write where DPTNO is equal to 10. So if I run this, so we have 934, 839, 782, and same are there in the bonus 934, 839, 782. So let's go with so we can say the employee bonus table is for the department 10 only, right? Now the requirement is I want to see the result in a single row where the first column will be department number and the second column will be the total sum of salaries from the department number 10, and the third column will be total bonus for the department number 10. So that is the requirement. In a single row the result should be appear. So let's start. So I'm saying I'm going to use the, for example, select star from EMPE. So instead of star I'm going to use some specific fields, EMP number, E dot E name, E dot salary, that is the total salary column from the employee, and E dot DPTNO from the employee number, employee table. And so let me make it and also we need bonus, right? So for that E dot salary multiplied. So since we have bonus in the form of bonus type, we don't have the direct number from the bonus, so I'm going to use the case statement. Case when, so here I'm going to use employee comma EMP underscore bonus as EB. When EB dot bonus type is equal to 1, then 0.1. Okay, so now in the second one, if it is 2, then bonus value will be 0.2. else 0.3, and as we'll say like bonus. Okay, so now since I'm using the Cartesian product, I should use the where condition, otherwise it will give the 4 multiplied by 3, 12 rows. You want to see that? Okay, before that we assumed where DPTNO is equal to 10. Since the department number is in only one table, I am not using the alias there. So here see the total rows are 12. So that's why we need to use the where condition, where E dot EMPNO is equal to what is that second table, EB dot EMPNO. So even you can use the inner join, that will also give the same result set, 4 records output. So now we got 4 records because our employee bonus table is having 4 records, even though the employee table is having 3 records. So now to see this result set in single row, what should I do? I need to write a aggregate one more select statement on top of this data set. So let me copy paste the code to save some time. So here I'm writing another select statement on top of this data set. So the department number and sum of salary as total salary, sum of bonus as total bonus, and of course I need to write the group by function, group by deptno. Okay, now if I run this statement, I got single row, which is correct, but the problem is the total salary. Total salary is supposed to be 8,750, but we got 1,300 extra on the total salary. The reason for the 1,300 extra is we already saw in the inner query. So this 934 is repeated 2 times, but in case of bonus that is okay, 130 plus 260 is fine. But in case of salary, we are getting the duplicates here, and when I run the sum of salary, I am getting 1,300 number extra. So the simple solution for this is go with simple distinct salary. Okay, now if I run this, done, perfect, the result is correct. But the problem is, as we all know, distinct is not a performance optimized function when you use on big data set. Since this we are handling with the 3 or 4 records, it is okay, but when you run on million records, then distinct will perform very poorly, and that is one reason. And the second one, the data itself may go wrong. So for example, in a 100,000 company or 50,000 employees company, there is more probability 2 employees can get same salary, right? So in that case also, if you use distinct, then some rows will get deleted and you will get the less salary. In that case, the sum of salary will be less. So distinct is not valid here. So what is the next solution? Since we are getting the problem with the department employee bonus table, so let me write one query, simple query here. Select employee number and sum of bonus type from the employee bonus table and group by employee number. So if I run this query, so 934 now become 3. So the bonus types are get added. So this is also fine, right? When you multiply salary with the 10% and 20% and then doing the sum of those 10 and 20%, instead of that, if you directly multiply with 30%, that is okay, right? So technically this is correct. So in this case, I am going to use this aggregated data set in place of employee bonus table. So instead of using the raw data from employee bonus table, I am going to use the aggregated data set. So there is no change, right? Only this is same. Instead of employee bonus table as a raw data, I am using the aggregated data now. Now let's see. See, the result is perfectly correct, 8,750. So as mentioned in the title of this session, aggregate before calculate. So we are doing the aggregation first and then we are doing the calculation on top of the aggregation. Okay, so that is what the aggregate before calculate means. So whenever there is a duplicate record chance, so do the aggregation first and then go for the calculation. So before closing the session, I would like to show you one more solution, you can say alternate solution or one more solution. So here I am using 3 tables, but not actually 3 tables, only 2 tables, employee and employee bonus. But along with these 2 tables, I am also joining one more data set, which is from the employee table. I am doing the sum of salary here. So here we did the sum of bonus, right? So here I am doing the sum of salary and then that sum of salary joining with this result set, and I am taking the department number and total salary from this result set, from this aggregated data set, and then the total bonus is from this calculation and those 2 tables. Okay, so that is the solution So here also this is a Cartesian product, so we have to use two where conditions for 3 tables. If you are not clear about this alternate solution, just spend few minutes and you will understand there is nothing special in this. Just split the query into multiple parts and you will understand easily. If not, then let me know, I can definitely help you. So that's all for this session. See you in the next session. Until then, happy learning. Bye.